Okay, students, welcome back to next studio on continuous frequency distribution. So, in this class, we are going to discuss about the steps involved in continuous frequency distribution. So, here it is a third part on continuous frequency distribution. Continuous frequency distribution, right? So, it is a part three, wherein part one we discussed about the definitions. I mean, what do you mean by continuous frequency distribution, as well as the basic definitions of continuous frequency distribution, such as class interval, class limits, class frequency, midpoint of the class interval, then size of the class interval, right? So, in part two, we discussed about types of class intervals, such as inclusive class interval, in which upper limit of a class interval is not same as lower limit. Then we discussed about exclusive class interval. In exclusive class interval, upper limit as well as lower limit of the next class interval both are same. Then open end class interval, in which there is no specific information on either first class interval or last class intervals, sometimes both the class intervals. Then we discussed about equal class interval, in which the size of the class interval of, I mean, size of all the class intervals of distributions are same, then we call equal class interval, otherwise unequal class interval. The next, the next part is how to construct or how to create the continuous frequency distribution. For that, we have steps. So here now we are going to discuss about the steps involved in or steps to prepare continuous frequency distribution. The first step, right? The first step, that is identify the range of the given dataset. Identify the range of the given dataset by using following formula. It means that what? By using this formula, we need to calculate the range. Right. So range equal to maximum value minus minimum value. Right. What is the range? Range equal to maximum value minus minimum value. Say for example, right. Suppose I want to identify range of the one data set. For understanding purpose, I want to consider one data set, that is say pulse rate. That is pulse rate. So 60, 62, 68, 72, 74, 60, 63, 64, 66. Now, how to identify range of this data set? Suppose let us assume this is the data set of pulse rate of how many patients? 1, 2, 3, 4, 5, 6, 7, 8, 9 patients, right? So, data set of 9 patients about the pulse rate. Then how to find out the range? What range says? Range is nothing but maximum value minus minimum value. What is the maximum value? Maximum is 60 is maximum? No. Maximum means what? Which is the highest number. So here highest number is 74. Here highest number is 74. So range equal to maximum value. Maximum value is 74 minus minimum value, which is the minimum value 60. So what is the range? Range is 14, right? So minimum value is 60 and maximum value is 74. So maximum value minus minimum value, that is 14. So in this way, we can identify range of the given data set. Why we need the range? We are going to discuss in the step number 2. Is it clear? So in this way, we require range of the given data set. The second step is find the number of class intervals by using following formula, right? So I told you already, continuous frequency distribution means what? We have class intervals as well as frequencies along with their tally marks, right? So what I told, class interval as well as frequencies along with their tally mark, right? So that is what the continuous frequency distribution. But in my table or in my frequency distribution, How many class intervals are there? Right? How many are class intervals? This is what the number of class intervals. Right? How many are class intervals are there? Say, for example, here we have class intervals and frequencies. Class intervals and frequencies. I told you C1 to C2 with frequency F1, C2 to C3 with frequency F2, C3 to C4 with frequency F3, and so on up to Cn to Cn plus 1 with frequency Fn. So how many are these in number? How many are class intervals are there in my table, or how many are class intervals should I prepare, or how many class intervals should I consider? Right. So for that, we have the one formula, that formula is number of class intervals equal to range divided by class width, right? So already we found that how to, already we know that how to find out range, right? So what is that formula? Number of, here, number of class intervals is equal to range divided by class width, range divided by class width. So how to find out range? Already we found in the first step. Is it clear? How to find out the range? Already we know the in first step, that is maximum value minus minimum value. The thing is here important. The thing is how to identify class width. How to identify class width, right? So in your research or in your project, you need to consider class width on your own basis, which is multiple of 5. Why? Because there is no specific information in day-to-day life. There is no specific information on the class width. But for academic purpose, for your examination purpose, in a given data set, we used to mention the class width. We used to mention the class width. Suppose there is a one note point is there. What is that note point? If there is no information on class width, consider any number which is multiple of 5. Say, for example, you can consider any number such as 5, 10, 15, 20, 25, like that, right? If there is no information on class width, so you can consider any number which is multiple of 5. Is it clear? So, if, for example, 5, 10, 15, 20, like that. So, with the help of this formula, now we can find out the how many are class intervals are there in my frequency table, right? So this is our second step. Then third step, step number 3 is prepare a class interval, right? So you need to prepare a class interval, right? So using which method? Either you need to go for inclusive or exclusive class interval method, right? So already we know that what do we mean by inclusive as well as exclusive class interval, right? Don't go for open-end class interval and all, but here you need to go for the either inclusive method or exclusive method, or inclusive class interval or exclusive class interval method, and you need to arrange the class intervals in increasing order of magnitude and list out in the first column of the table, right? So inclusive and exclusive, already we know that, right? We need to arrange them in increasing order. We need to arrange them in increasing order, and we need to list out in the first column of the table. Is it clear? We need to arrange in increasing order, and we need to uh, fix, or we need to list out in the first column of the table, right? Again, students may have here confusion, like either we go for the inclusive method or exclusive method. In the notes or in the presentation, sir given that like inclusive or exclusive. So which method we follow, right? Again, we have the clarification about the method of class interval. See, as usual, your project as well as your research by default method is exclusive, right? By default method is exclusive. But whenever in academics and all, your for examination purpose, if the question is like prepare a continuous frequency distribution with the help of inclusive class interval, or prepare a continuous frequency distribution by using inclusive method, means you need to go for the inclusive. If there is no information on inclusive or exclusive, directly go on exclusive method, right? If there is no information on inclusive or exclusive, by default method is exclusive class interval. I hope the first three steps are clear. So fourth step, step number 4, assign a tally mark by observing each and every observation of the given data set, which is same as the previous one. Previous one means what? For a discrete frequency distribution, step number 2 and step number 3 are here, step number 4 and step number 5, right? So step number 5, count the total frequency and write down in the frequency column, right? What I'm saying, step number 5, count total frequency and write down in the frequency column, right? So this is what these are what the steps to create or to construct continuous frequency distribution, right? So, okay. So once again, I'm going to just recapitulate. Step number 1, identify the range by using the formula maximum value minus minimum value. Step number 2, find the number of class interval using this formula. That is number of class intervals equal to range divided by class width. Next, if there is no information on class width, consider any number which is multiple of 5. Then in step number 3, you need to consider the either inclusive method or exclusive method. In step number 4, you need to assign the tally mark. In step number 5, you need to count the total tally marks and write down in the frequency column, right? So these are what the 5 steps involved in construction of continuous frequency distribution. Now, in next slide, we are going to discuss examples on continuous frequency distribution. It means that how to create continuous frequency distribution, right? So here example is going to continuous frequency distribution, construct continuous frequency distribution for the following data related to ages of 50 patients, right? So here what they given, which factor they given? They given age of how many patients? Age of 50 patients, right? So age of 50 patients died because of a certain disease, right? It means that due to certain disease, due to certain disease, some patients are died. Some patients may say 50 patients they consider. And what they collected? They collected the data at which age they died. Is it clear? At which age those people died? I mean, those 50 patients died because of a particular certain disease. So we need to arrange or why we need to arrange. Say for example, my question is how many patients are died from the age 25 to 30? How many patients are died from the age 30 to 35? To do analysis, we require such thing. I mean, the age factor, right? So at which age that particular disease is highly affected, at which age that particular disease is, affected with very low, like that. To do analysis, we require the systematic arrangement of the age groups or ages of these 50 patients, right? So here now we are going to uh, prepare the continuous frequency distribution, right? So here we need to follow the steps as usual, right? So step number 1, what I told, step number 1, identify the range. Here in the previous slide, what I given the step number 1, identify the range by using the following formula. Right? It means that first step is uh, determine the range of the data set, right? What is the first step? Range of determine range of the data set, right? We need to determine the range of the data set. So what is the formula to find out the range? Range equal to maximum value minus minimum value, right? So I'm going to write the short form MIN, that is minimum, MAX is maximum, right? uh, Maximum value minus minimum value, right? So now we need to identify which is the maximum value in the given data set, right? So we need to search 55, no, 55 more, we have 60, which is greater than 55. So up to here, 60 is the highest, 60 is the highest, 60, 60. Okay, again, one more time, 60 repeated, 61. Okay, now here we got 61 is the highest. 40, okay, now here we got 66 is highest. So continuously, mm, okay, 66 is the highest. Next, in we need to search the minimum value in the data set. Minimum is which is smallest. Uh, by observation, uh, smallest is 28, and Here we got that maximum 66. Okay. This is what maximum value and this is what minimum value. So now what is the range? What is the range now? Range equal to maximum value is 66. Minimum value is 28. 66 minus 28. The answer is 38. This is what step number 1. Step number 2. Step number 2. Right. So what is the step number 2? Identify the number of class intervals using the formula range divided by class width. Right. So number, this in mathematics and statistics, this hash symbol represents number. Number of class intervals is equal to range divided by class width, or simply I am going to write width. So range, what is the range? 38 divided by, just to read the question, is there any information on range? No. So what I told, whenever there is no information on range, you can consider any number which is multiple of 5. Say for example, 5, 10, 15, like that. 5, 10, 15, 20, and so on. So like that, you can consider any number which is multiple of 5. So here I will consider the number 5. Here I consider the number 5. So 38 divided by 5, that is 7.6, approximately 8, right? So in my table, there are 8 class intervals are there. There are 8 class intervals are there, right? So in my table, there are 8 class intervals are there, right? So now step number 3, that is also important. What is step number 3? Using inclusive or exclusive class intervals, you need to prepare the class interval. But in the question, there is no information on inclusive or exclusive, which is the default method. Default method is exclusive class intervals, right? So now we are going to consider exclusive class interval. Exclusive class intervals means what? Upper limit, sorry, for upper limit is the same as lower limit of the next class interval, right? So now in step number 3, right? So in step number 3, we are going to prepare the class intervals, use the help of exclusive class intervals, right? So here, from which value we start? So minimum is 28. So better I will go for 25 onwards, right? So uh, 25 to 30 is first class interval, and I am using exclusive. So upper limit is same as lower limit of next class interval. So 30, 30 same. So 30 to 35. Then 35 to 40, 40 to 45, then 45 to 50, then 50 to 55, then 55 to 60, and 60 to 65. At the end, we have 65 to 70. Why I need to stop at 70? Because what is the maximum value here? Maximum value is 66. So it is sufficient to consider up to 70, no problem, right? Okay, now I need to consider the table. So this was step number 3. Step number 4. Step number 4. What is the step number 4 says? Step number 4 says that you need to create the table. So here I will consider age group. Oh, sorry. First I need to consider the table. Okay. So first I used to consider the table. So here age group is the variable here, right? This is what the first column of the table. Second, we need to consider tally marks. Tally marks. Then at the end, frequency. Here, what is the frequency? Frequency is nothing but number of patients. Number of patients, right? So I'll start with 25 to 30. Next, 30 to 35, 35 to 40, 40 to 45, 45 to 50, 50 to 55, 55 to 60, 60 to 65, and last one, 65 to 70. Right. So this is what the considering of class intervals. Right. So by observing each and every data, we need to what we need to do? We need to mark a tally marks. We need to do mark a tally marks. Right. Okay. Go back to data set. What is the first observation? 55. So first observation is 55. So 55, it has two here as well as here. I already told you while explanation of exclusive class interval, prepare always lower limit. Is it clear? Prepare always lower limit. So wherever you have lower limit 55, you need to mark there. So I marked one tally mark this 55. Then next observation is 60. Again lower limit. Next observation is 47. So 47 lies between these two. Next observation is 37. 37. Next is 33, 38. Next is 40. 40. Prepare always lower limits. Next is 28, 45, 35, 46, 52. Next is 42. Next is 47. Next is 35. So we have one more 35. So four vertical lines and one diagonal line that represents a group of five. Next is 33. Next is 48, 48, 49, 36. One more 35, 30, 45, 46, 60, 33, 61, 46. The next is 66, 33. Next is 45. Next 29. Next 49. Next 42. Next 31. 45. 28. 28. Next 43. 50. Next 48. Next is 45. Next 35. Next 36. Next 33. Next 60. Right. So this is what the distribution. This is what fourth step. Now fifth step, we are going to calculate number of patients. So here 3, here 1, 2, 3, 4, 5, 6, 7, here 10, here one group means 5 plus 4, 9, 1, 2, two groups plus 4, 14, 1, 1, 4, 1. So here what is the n? So 7 plus 3, 10, 10 plus 10, 20, 29, 29 plus 14, 43, 43 plus 1, 45, 46, 46 plus 4. Somewhere we mark one extra, but the total is 50 here. We are going to get the total is 50, right? Uh, 10, 20, 21, 33, 43, 43, okay, 50, right? So in this way, we are going to uh, we are going to construct the continuous frequency distribution. Now we are going to, oh, I hope it is clear. So now we are going to discuss some more example on continuous frequency distribution. See, it is a different kind of example when compared to last one. What is the example? Construct a continuous frequency distribution using inclusive classes, right? What they given? They mention class, which type of class interval you should consider. That is inclusive class interval. Inclusive class intervals means what? Upper limit of the class interval is not same as lower limit of the next class interval. Is it clear? I repeat that upper limit of the class interval is not same as lower limit of the next class interval. Then considering the class width, wow, they given their class width also, right? They given class width also for the following data. They given the data set. So solution, step number one. This is step number one, finding the range. Range equal to maximum value minus minimum value, right? What is the range? Maximum value minus minimum value. So identify the range. What is the first maximum value? I mean, not first. I mean, what is the maximum value here? Maximum value is 63, right? So here we have 63 here, and minimum value is 5. No, 2. Minimum value is 2. So range equal to 61. How? 63 minus 61. Step number 2. What is step number 2? Find the number of class interval, right? So here, number of class intervals is equal to range divided by class width. Range is 61 divided by class width. They mention in the question class width, that is 10. So 6.1. So approximately 6.1 means approximately there are 6 class intervals are there, right? So approximately there are 6 class intervals are there, right? So next is step number 3. That is what? Creating the class intervals using the class width. Creating the class interval. So minimum value is 2. So I will directly start with 2 with class interval 10. With class interval 10, right? So step number 3. 2, 2 to next 10 numbers, right? So that is 2 to 12 because class width is considered as a 10. Next, uh, 13. Why I consider 13? Why should I should not consider 12? Because it is inclusive class interval. Upper limit of the class interval is not same as lower limit of the next class interval. These should not be same. Hence, only we can say the inclusive class intervals, right? So next, up to 23 is completed. Okay, 24 to 34. Next is 34 to 40. Sorry, not 34. Why? Because it is inclusive. 35, yeah. 35 to 45. Next, 46 to 56. Then 56, 57 to 67. Right, we need to stop here. Why? Because maximum value I got 61. Sorry, 63. Maximum value is 63. So I should go for more than 63. So according to our systematic pattern, maximum value we can consider up to 67. Right. So this is what step number 3. Next is step number 4, that is considering the frequency distribution. That is step number 4. Right. So here I will consider the first column, that is variable. First column, that is Variable. Variable means what? We are considering the class intervals of different variables. Then tally marks. Then we have frequency, right? So variables are nothing but class intervals. These are here 2 to 12, next 13 to 23, next 24 to 34, next 35 to 45, next 46 to 56, next 57 to 67, right? So this is what the empty platform of continuous frequency distribution for this example, right? This is what empty platform for this example, right? So now first observation is 31. So 24 to 34, here it exists 31. So I will change the pen color which, right? So what is the first observation? 31. Next is 30, 30. This is also lies between this. Next is 44. Next is 44. Where exists 46 to 50. Sorry, here 44. Next is 6. Next is 42. 42. 42. Okay. Next is 13. 1, 3. Next is 30. 302. I mean 2 times 1, 2. Next is 22. 22. 22. After that, we have 31. 31. Next, 30. Next, 29. Next, 12. Next, 21. Again, 22. Next, 19. 1, 9. Then 63. Then 30. Next, 20. 21. 38. 44. Next is 7. After the 7, we have 39. Next, 39. 17. 52. 18. 25. 32. 53. 46. One more, 46. Next, 19. 24. 20. 31. 36. 5. 37. 14. 32. 44. 15. Then 23. Next, 45. Next, 41. Next, 15. Next, 6. And last one, 28. Right. So this is what the frequency, I mean, assigning the tally marks. Next is number of frequencies, 6, 15, 10, 14, 10, 4, 1. So here also n is 50. So this is what the example on, I mean, second kind of example on continuous frequency distribution, right? So now these are continuous frequency distribution. So here we got what do you call it? The uh, continuous frequency distribution as well as the examples on continuous frequency distribution. Next one, we have one small topic that is called cumulative frequency distribution. Cumulative means what? Just you go on adding, right? The next one, that is small topic. It is cumulative frequency a cumulative frequency distribution, right? Cumulative frequency distribution is nothing more, just simply you are going to add. But how to define it in statistics? Cumulative frequency distribution may be defined as total frequencies, right? So what we are going to define, cumulative means what? Cumulative means what? Total frequencies, right? So then we have two types of cumulative frequencies. One is less than cumulative frequencies and one is more than cumulative frequencies. Then why we need this cumulative frequency? Because to do further analysis, right? So what I told, one is less than cumulative frequency, one is less than cumulative frequency. One more is more than cumulative frequency, right? So then how to define the first one, that is less than cumulative frequency? These are also types of frequency which are less than upper limits. Is it clear? So these are also frequencies which are less than upper limits. Is it clear? And here more than cumulative frequencies are nothing, these are also frequencies which are lower than, sorry, mm, opposite, which are more than. Here first one is less than upper limit. Here more than lower limits, more than lower limits, right? So less than cumulative frequency means what? These are also types of frequencies in which these frequencies are less than upper limits, which is already mentioned in the notes PDF. They are already sent to you in the group. Then more than cumulative frequency means what? These are also types of frequencies in which frequencies are more than the lower limits, right? So then how to identify those uh, less than cumulative frequency and more than cumulative frequencies? Now, just I will go back to this uh, variable as well as variable and I will go back to here, this cumulative frequency distribution. So we need variable and frequencies. Now I'll demonstrate one example on cumulative frequencies, right? So here we consider variable and frequencies, right? So what is that variable? 2 to 12, we have 6. Then 13 to 23, we have 15. Next 24 to 30, so 24 to 34, we got 14. Next 35 to 45, we got 10. 46 to 56, we got 4. 57 to 67, we got only 1. So that is total. Our capital N is 50. Right, and now how we are going to find out LCF? LCF means what? Less than cumulative frequencies. Here, short form of less than cumulative frequencies, LCF, less than cumulative frequency. MCF means what? More than cumulative frequency. Right. So how to find out less than cumulative frequency and more than cumulative frequency? Now just check here. Less than cumulative frequencies are nothing but what? Less than cumulative frequencies are, these are also types of frequencies, or these are also numerical values which are less than upper limits. Less than upper limits means what? Upper limit is 12. Less than 12 is here 6. Here upper limit is 23. Less than 23 are 15 as well as 6. That is 21. Here less than upper limits means what? Less than 34. 14 plus 15 plus 6. That is 35. Yes, 35. How we are going to find out LCF value? Just you go on adding frequencies. First one remains same as it is. Then for this, just you go on go on adding as it is. 6 plus 15, 21, 21 plus 14, 35, 35 plus 10, 45, 45 plus 4, 49, 49 plus 1, 50. 49 plus 1, 50. Then how to find out more than cumulative frequencies? But it says more than cumulative frequencies means what? These are also numerical values, or these are also frequencies which are more than lower limits. See, more than 2. Here lower limit is 2. More than 2 means all frequencies are. So here 50. More than 13. 2 to 12 we have 6. So more than 13 are just we need to subtract 6. That is 44. Right. So here how to find out MCF value means 50 minus 6. 50 minus frequency 44. 44 minus 15. Right. So next cumulative frequency is 44 minus 15. That is 44 minus 15 is 29. So 29 minus 14. 29 minus 14. That is 15. 15 minus 10. 5. 5 minus 4. 1. Right. So these are what? More than cumulative frequencies. Very simple trick you should remember. To find LCF values, just you go on adding the frequencies. To find MCF values means more than cumulative frequency values, just you go on subtracting the values. Right. Then how to cross verify? Whatever we found, those values are correct or wrong. How to cross verify? See, this total is always equal to this last value. This is clear. This total is always equal to this last value, and this frequency last is same as this MCF last value, right? So these two values are equal means these whatever you found LCF values are right, and this value as well as this value both are equal means whatever you found MCF those are right. So this is of concept of construction of continuous frequency distribution as well as some examples. See, this it is a recapitulation of class. First, we discussed 5 steps. What are the steps involved in the construction of frequency distribution? After that, we discussed about one example of exclusive type and without basic information on class width, right? So next is one example on inclusive class intervals with the information of class width. After that, we discussed about more than cumulative frequencies and less than cumulative frequencies. Then one example for the demonstration of how to calculate less than cumulative frequencies and more than cumulative frequencies. The purpose of learning more than cumulative frequency or less than cumulative frequency or simply cumulative frequency to identify median. In further classes, we are going to discuss under heading of measures of central tendency. To find out median, we require the less than cumulative values. Right. So I hope there is no doubt in the examples of continuous frequency distribution as well as these steps involved in continuous frequency distribution. So now here it ends with the frequency distribution. Next class onwards, I will start with diagrammatic and graphical presentation.